And joining us now to talk neuroscience and education, here's Alanna Mitchell. She is the 2008 Atkinson Fellow in Public Policy, and she has investigated the use of neuroscience to improve education. And as I welcome you here tonight, tell me where you got the idea to put those two things together in the first place.
Well, for me, I am interested in biology. So to me, I looked at how my kids were learning in school, and I thought to myself, why is it that when they're learning, they really are learning? What's happening in their brains biologically? How do we know when teaching is working? So of course there's a biological answer for that. So it just went back to my love of biology.
How old are your kids?
16 and 19, yeah.
And you thought you could figure out what was in the mind of a teenager? I'm sorry, what led you to that conclusion?
It's insanity.
Yeah, apparently. All right, well I want to start by just reading an excerpt from one of your pieces here, and then we'll go on and chat from this. To many neuroscientists, you write, today's mainstream education system is mired firmly where medicine was during the Middle Ages. Practices continue based on tradition, not science, just as medieval doctors used leeches to bleed patients without knowing whether it worked. Now that's a pretty, stinging indictment of the way things are. Is it really that bad?
Yes.
It's that bad?
Yes.
We have no clue.
Well, what we have is observation. You have teachers who are wonderful teachers who are teaching effectively, and we've all had some of them. But they're not sure why the way they teach works. So they can't actually say, okay, this is what's happening in the brain, and that's why this particular kid is learning and doing well. What they do instead is say, this kid is doing well on a test. So there's observational stuff that they bring to bear on the practice. But the biological element of it, what's happening in the actual brain, it has not traditionally been part of education.
So the underpinnings for whatever, 100, 150 years of education have all
2,000.
been 2,000 years of education have all been observational as opposed to neuroscientific.
Correct.
And you're trying to bring a more biological aspect to this.
I'm saying it would be fascinating to look at it through a biological lens, so through a biology of the brain lens at education. What would happen? What could we unleash if we did that?
Okay, I think one of the interesting things I learned in reading your pieces is that, my hunch is we're under the assumption that some kids are born smart and some kids are born stupid.
Yes.
And sorry, stupid's a bad word, but you know what I'm saying.
That's exactly the language people use.
Right.
You're exactly right.
And, some get the breaks and some don't get the breaks.
Yes.
Some get good teachers, bad teachers, and so on.
Right.
You tell us they actually kind of all start in the same place.
They pretty much do. 100 billion neurons in the brain of a newborn, whether it's born here, whether it's male or female, whether it's born in a village in Africa, whether it's born rich or poor. You've got 100 billion neurons in the size of a little tiny baby newborn's brain. And the difference between that baby's brain and your brain is the connections among those neurons. So it's not to say that there's no there's no, nature element to this, but neuroscientists are now figuring that it's maybe 20% nature and maybe 80% nurture. So the building of those connections among those neurons is what actually creates the learning material of the brain. It makes it a human brain as opposed to an infant, undeveloped brain.
So getting a good start in whatever education system you are in is 1,000% crucial, right?
It begins way before you get to school. I mean, of course, it's that first, I don't know if you have kids, but that first, those first days and weeks and moments when you're connecting with the child, what you're doing is locking into their brain. You're teaching them through your own brain, which is fascinating. And there's a bunch of scientific stuff that will show how that works.
I got to tell you, I do have children, and I have always assumed the opposite of what you just said.
Yeah.
I have always assumed that 80% of whatever was going on was nature.
That they were just born with it.
Right, and 20%, maybe was what the education system, their parents could provide. And what you've told us is very disquieting, because we really could have screwed it up then.
Well, more importantly, you can really make it better. So what you've got here is a platform. Your brain is a platform at birth. So it doesn't matter where you're born. It doesn't matter what color you are. Your skin is. It doesn't matter whether you're a boy or a girl. Effectively, a brain is a brain is a brain. It's a species, right? And so most of those brains work the same way. And this is barring catastrophic problems in gestation and
sure.
toxins.
You're saying all things being equal.
All things being equal, without that basically it's the same brain. And what happens is that it has an enormous potential, which are some of our social practices, including some of our educational practices, shut down. So instead of shutting down all of these potentials I'm saying, let's build the possible school. Let's actually try to plug into how the biology of the brain works and open it up and try to just build those connections.
Okay, more on that in a second. I mean, you've gone beyond saying there's potential here that we're not tapping into. I think you've said intelligence is not fixed, but almost limitless.
Yes.
Limitless?
Well, compared to what compared to what we now understand intelligence to be, yes.
So we could be doing, if we just took a different approach, so much better than what we're doing right now. That's what you've concluded.
That's what I've concluded.
How does a person's own belief in whether or not they are smart affect their ability to learn?
I love this question. This is such a great question. If you think you can learn, then you can learn. They can, and scientists have done a bunch of ways, they've looked inside the brain. Let me back up a tiny bit. We used to not be able to see what was happening inside the brain, apart from looking at a corpse. Then you could see what was happening in the brain, but you couldn't see how a brain learned. Because we have functional MRIs and other types of mechanisms for looking inside the brain, you can actually see the brain learn. It's absolutely amazing to watch. You can see it light up, you can see the connections being formed, and as all those connections are being formed, the brain is changing structurally. We are sculpting the brain as we learn. So your brain is going to be different after this discussion.
God willing.
No, it will be, and mine will be too, because we are learning something from each other, and our brains are therefore changing quite microscopically, but nevertheless, they're changing. So isn't it? It's the most amazing thing. So if you think you can learn, then your brain is set up to accept information and for those connections among the neurons to form. And they've done a bunch of studies, so they've looked at how this works inside people's brains. And here's a great example. This is my favorite example. So it was done at Stanford University, and they had a bunch of second-year students. I believe it was second year. They were all male. They were all of sort of equal, achievement in school. And they sat them down and asked them to write a test. So all these university kids wrote a test. They took another, and that was the control group, and their marks were just about exactly where the researchers thought they should be. They took another group, again, all male, all second-year university, all in the same basic achievement level, and some were black and some were white, as with the first group. Except in this case, they asked the black kids, the black students, to tick off on a box whether they were black or white. And as soon as the black kids ticked the box saying that they have black skin, their marks dropped dramatically. So part of it is just what you think the stereotype is telling you about who you are and how your brain works.
That's heartbreaking at some level.
I know. It's the same with gender. It's the same with poverty. It's the same. I mean, I'm not trying to say that it's the only answer. It's just that it's an element of what we could be thinking about as we're trying to teach our children.
In some respects, it goes back to that line our parents all taught us, which was, if you think you can, you're right. If you think you can't, you're also right. Right?
That's actually sadly true. But so much of it is just your mindset. Do you think, for example, and this is one of the ways in which education could really, really be affected. If you and your teacher think that you can't do math, then you actually can't do math. If you and your teacher think that maybe you're not doing the math right now in the way that everybody hopes you would, but that you can learn how to do that you really can build that knowledge, and not just that knowledge, but all of the different types of knowledge. If you can build all that on this platform that is the brain, then you're going to approach all of this stuff quite differently. But instead what we have, just as we were talking about before, you have the concept that there are some kids who are really able, really bright, and some kids who just aren't. And they're never going to get there. But if you tell those kids that they can't learn, then they're not going to learn. And if you tell them that they can learn, so if you take a group of fairly disadvantaged children who are not doing particularly well in school, and they've done all this, and you tell them, actually, you know what, your brain is malleable, you can learn. They say, oh yeah, really? I'm not fixed? I'm not a dumb kid? And you say, no, actually, I'm looking at your brain, I'm looking at the scan, and you can learn just exactly the same way as everybody else. And they say, oh, okay.
Off to the races they go.
And then they go. And it's fascinating, because some of this stuff is attitudinal and conceptual.
Well, let me follow up. You mentioned genders a second ago, and I want to follow up on that, because later in the program we've got Chris Spence coming on, who's the new head of the Toronto District School Board, who wants to do some experimenting with all-boys schools.
Right.
How does that fit in with what neuroscience is telling us, the all-boys surroundings?
If you look at that through a biological lens, there's no real reason to do it.
Now that's going to come as news to him.
I know. I've been reading about his research and his his ideas about this. And thank God there's somebody there really thinking about education in novel ways, and full marks for that.
Okay, but you don't think he's onto something?
No.
So what's going on?
It's not that I don't think so. It's that the neuroscience would tend to suggest, okay, here I am, modifying my words, would tend to suggest that there's no real benefit to that necessarily. So, and there are some risks. It's not to say that there's no benefit at all. It's just that the risks can be quite large. So what you do there is you take these kids who are not doing, a whole group of kids, boys, who are not doing as well as a whole group of girls, and you say, okay, that means they learn differently. And so we're going to set up a school to make sure that they learn differently. Actually, they don't learn differently. We have taught them, in some cases, to learn differently. But all of those great ideas that this superintendent, this wonderful man is thinking about incorporating into schools for boys would be fabulous for girls too.
But it may well be that we've set up our school system in such a way that we can only teach it one way, and it's not going to work for those guys, and therefore, neuroscience or not.
Why? Why? Why should it be that we've got a system and we can't change it?
Well, because change is hard.
No, but what's our mandate? What is our public education system for?
Yeah, make sure every student reaches his or her potential.
That's the concept.
Yeah.
And that's a really fundamental plank of democracy, frankly. Mm-hmm. Like, if it's not for that, then what's it for? That's what I would ask. So what is the harm? Where is the downside in making all of those great teaching practices and experimental practices? I'm not saying that he's got the right ones, but I mean, he's thinking about all this stuff, which is great. What's the disadvantage of saying girls can do that too? Who's disadvantaged by that?
Okay, Alanna, let's talk marshmallows, okay? This is a great story. I love this test. I'm sure I'd flunk this. It's called the Marshmallow Test, you tell us, and some neuroscientists believe it is a critical first step needed to improve schooling. It's going to be huge, says Martin Westwell, a neuroscientist at, is it Flinders University in Adelaide, Australia?
Yeah.
Adding that many studies show it foretells success in life more accurately than how well a child can read or do math. This is a great test. Tell us about the Marshmallow Test.
Okay, so the original test was in the 60s, and they didn't understand really how important a predictor it was at the time. But it's the 60s. They're doing all sorts of experimental stuff, and they put these kids in a room and say on a
how old?
Well, 4.
Okay.
These 4-year-olds in a room and say, if you can wait for 15 till I come back into the room. If you can wait till I can come back into the room, you can have 2 marshmallows or even a plate of marshmallows. But if you eat one before I come back into the room, then you only get 1.
Yeah.
So it's a test. So these kids, they're sitting on their hands, they're doing this.
It's a test of self-discipline, basically.
It's a test, and actually they call that self-regulation, or even very specifically executive control. And I hate these jargony terms, but it's called executive control.
So
and basically,
you get more if you wait, basically.
You get more if you wait. So what is your goal? If your goal is to just have 1, then of course you're just going to eat it. But if your goal is to get more, and for all the kids, it was something that they really wanted. Marshmallows was one of some of them were candy, but mainly marshmallows. Marshmallows was the thing that they really loved, and they really wanted a lot of them. So the goal overall for these kids was to get as many marshmallows as possible. Could they achieve the goal? So the kids who could achieve that goal, in other words, wait the 15 minutes by whatever means, make sure that they didn't eat a marshmallow before the person came back in, those kids tended to do incredibly well at school. And so this whole theory emerged over they went back to it in the 80s, and in recent years, this is fairly recent, 10 years, they've started thinking about the whole executive function part of the brain, which is right here. Mm. And unlike some things about the brain, some structures of the brain, some capacities, you can teach executive function.
Ah, well, that's good news, because I think, if I remember, 2/3 of the kids flunked the test, right?
Exactly.
They wanted it right now.
They wanted it right now.
So they didn't have that so-called executive function or whatever.
But you can teach it, just as you can teach other stuff. So if you can teach those functions very deliberately, and this means really thinking about what you're teaching and reinforcing it, and reinforcing those skills as you go through school, not just in, when the kids are 4, but when they get to be, say, the critical age of 13, when they get to be 17, when you get to all of those other really, the stages at which this huge brain of ours just makes these big leaps in maturation. When you get to those points, and and as support, you get to build those skills. You get to build that part of your brain.
Are neuroscientists going so far as to say that, okay, that's one example of where it can be taught, maybe we can bring these principles to bear for students who have attention deficit disorder?
Well, strangely enough, that's where most of it started. Most of the research on this started with kids who are not typical kids. So they have some sort of difficulty. And that's how this whole theory developed, and it was through examining the brains of those atypical kids that researchers really found this stuff out. So there's been some tremendous work done with autistic kids, with ADHD kids, and some of it, not all of it, some of it has to do with teaching these executive functions, which is self-control. It's not compliance, which is a completely different thing. It's not, I'm doing this because someone told me I have to, and you know, it's because you learn how to plan, you learn how to do these higher level human functions that have to do with this incredibly powerful part of the front part of our brain, which is where these functions are stored.
You write that neuroscientists have concluded that, quote, emotional thought is the platform for learning, memory, decision-making, and creativity. So take all of that, and what are the implications for the classroom of that?
Emotion is part of it. Emotion is absolutely the price of admission to learning. If you don't have emotion, you do not learn. If emotion is not involved in a positive way, you do not learn. And if you've got strong emotions that are sort of shutting down the ability of these neurons to make these connections, so say you found out, oh, you know, last night that your parents are getting divorced, or you're worried about, you know,
where your next meal's coming from.
When your next meal's coming from, or you're hungry, or any of those things can shut down the ability of these neurons to talk to each other, to build these connections, which become stronger and stronger as they're more built.
Is the modern education system missing out on that key finding?
There is absolutely no question that it is, alas. But this is a very new finding. I mean, this is not a blame fest. I mean, this stuff is really, really new. It's only 10 years old. That, you know, that neuroscientists have said, oh wow, there are all these questions that educators could let us peek into. So, because neuroscientists haven't got a clue really what goes on in the classroom, but they can tell you how the brain works. Educators don't really know what's going on in the brain, but they know what's happening in the classroom.
How do we get these people together?
You have to, if you get these people to think of what that could mean. Wouldn't that be amazing?
Is anybody doing that? Getting these people together in a room and saying, can you hammer something out?
Very few, but it's happening in a few places in the world. So Harvard is one of the great places where it's happening. One of the neuroscientists who is at Harvard is sort of at the epicenter of the movement. His name is Kurt Fisher. There's some stuff happening at Oxford.
Anything in Canada?
Not that I know of. A little bit, not much. Not much.
Okay, let me read another excerpt then. This one's about kites. You remember this story. The senior kindergarten kite-making project at Toronto's Institute of Child Study started by accident. Teacher Carol Stevenson says it evolved out of a months-long chat about China, which took a side trip into papermaking and finally meandered into a class-wide fascination with kites. That led to a 4-month extravaganza of 5-year-olds designing, constructing, testing, researching, seeking expert advice, redesigning, reconstructing, and retesting kites. I never quite know which direction it will go, says Stevenson. It could have gone anywhere. Teapots, clay making, anywhere. Okay, you tell us, I mean, you've told us about this story because you think it's important for good education strategy, but I guess we need to know why would all of this and making kites and spending 4 months making kites, why would that lead you to better educational outcomes?
That's a really good question and complex. One of the reasons is that it allows the children to formulate their own. Okay, so again, this goes back to, can the neurons talk to each other? Can the neurons connect, and as they connect, they will build stronger pathways? So that's the basic element of learning. So the reason this is so effective, the reason this is such a fabulous example of this stuff at play, is that it opens up the ways for these neurons to talk to each other, to communicate electrically to each other. So these kids are really interested. I mean, it's come from them. It's something that they are directing. So it's not some teacher saying, oh, well, you know, come into the classroom today, we're going to make a kite. And they say, well, okay, you know, like, and there might be some interest. This is something that they're deeply, deeply involved with for months. And they get more and more involved in it. And they begin to think in terms of not just cutting out paper, or not just making a drawing. They begin to think in terms of how does this thing actually fly.
And what age children are we talking
These
about?
These are 5. These kids are 5, and they're talking about aerodynamics. And there's no question that any kid could do this.
That's fascinating that on the one hand they would be talking about such a sophisticated subject, but I'm at some level a bit surprised that it doesn't go the other way, that they don't start saying, oh my goodness, I've been doing this day after day, week after week, I'm tired of this now.
Yeah,
Why doesn't it go that way?
I suppose it could go that way. Part of it is the skill of the teacher who's also on this journey with them. So there's very much a sense of wow, we're finding out about kites together. And it sounds really simple, and in some ways it is very simple, but it's a different attitude towards education. It's not the teacher standing up there like the Priestley model from 2,000 years ago saying there is a higher level of knowledge that I have that you don't have, and I'm going to endow that to you. This is, we're exploring, we're becoming brain explorers and brain builders together as we go through this year. And this is the project that everybody's fascinated with. Okay, there was one kid who wasn't super interested, one kid out of the 22 who wasn't super interested. And so he found another way in. He was interested in the color blue that year. So,
where'd that take him?
A whole bunch of different places.
He's a Leaf fan, I guess.
A whole bunch of different places. And so, but she found a way to, get him involved as well. And at one point actually make him the hero of the class over this thing. And it was, so there were ways to appeal to their sense of them exploring inside their brains and together and talking about it and learning about how they learn, which at 5 is really quite exceptional.
From the sounds of things, though, and after reading your reports, it sounds like we've got to take the education system and we've got to put it inside just a huge shaker and give it a big shake and have something entirely different come out the other end if we want to improve the outcomes. Is that fair to say? I
think we have to teach teachers differently. We have to rewrite, retool the curriculum. I know this. It sounds like we do this every 20 years. There's a new fad, but this one strikes me as something that's doable, and there's a reason to do it. There's a reason to say that it works. It's not just a politician saying, oh, I think it's all about back to basics because that's the way I learned, or it's not about let's bring back the strap because that's how my grandmother did it. It's not about those kinds of things. It's about actually you can see how the brain is working, and so there's a level of empirical evidence there that I find really compelling. Does it mean a full retooling? Not necessarily. It means a different way of thinking about it. It means teaching teachers about neuroscience.
And is that happening? I don't know how much hanging out in teachers' colleges you do, but are we training teachers differently enough to have this be possible?
No.
And why aren't we?
Well, there's a good question.
Well, what's the answer?
Well, we should be, we're not.
We should be, and
we're not.
Where does it start?
Where does it start?
Yeah.
Well, I think it starts with parents. I think it starts with parents. I mean, if you know and I know, I mean, I've got a 16-year-old, so I'm really interested in how the teen brain works, and that's one of the other things that got me interested in this. How is it that this kid with this huge, big, powerful engine is trudging off to school, and not, he's not changing the world because he's got it in him, just like all his friends do. I mean, the teen brain is just this miracle, right? It just goes through all of this change. So, I started thinking about how do we do this, and I don't know.
But our assumption is that if you're going to have a massive change in approach, policy, attitude, whatever you want to call it, this kind of thing usually comes top down from the Ministry of Education at Queen's Park.
Imagine the power if parents realized that the schooling system as we have it now actually works against the way kids should learn.
But we're learning new things. I know we had John Rady on a couple of weeks ago.
Yeah.
And I mean, here's a man who says just by 45 minutes of vigorous exercise every day, you can improve educational outcomes because they're readier to learn.
Yeah, there's a biological reason for that. Again,
right.
If you look inside the brain and see what's happening because of that, it's one element. It's not all of it.
Sure.
Though. Imagine doing that and having some of the ideas that the neuroscientists are talking about.
So you've got all this new stuff coming out now. Why? How
do we incorporate it?
Yeah.
Well, I put my faith in parents. I mean, because parents are really interested in this stuff.
Parents are busy.
Well, parents
Both
also.
parents are working. They're
Sure.
It's really hard.
They can, yeah, but if politicians are really sensitive to this stuff. We're not the only country. It's not just Toronto. It's not just Ontario. This is a worldwide phenomenon. There is a movement happening in education and neuroscience across the world. China, Japan, India, certainly the UK, many parts of Europe. There's a movement in the US.
Yeah, but let me make sure I have the characterization right, though. Are you saying that neuroscientists and educators are at odds with one another, or is it more a case of they just need to be introduced to one another?
They need to be introduced to each other. They come from different
worlds.
They do.
They
really come from different worlds, and there has been a bias in education against some of the science, which is very strong in teaching colleges. Mm-hmm. So some of that is just as we learn, as we become more multidisciplinary in the way we think about these things. I think there'll be some opening up. What's the breakthrough? I don't know. I think it's still too early. I know that if we think about education in a different way and try to press for some of this stuff, You know, maybe we should be talking with the premier. Maybe we should be talking with, you know.
Well, he says he wants to be the education premier. That's what he wants to go. I mean, that's where he wants to plant his flag. He said it many times.
He has. This is pretty new. It's hard to know exactly which policies would work for this, but some of them are really clear, and some of them could be implemented right away.
So tell me that, last 30 seconds here, for frustrated parents who, you know, when they want to get the smallest little change to the way their children are being educated, and you run into that, you know, educational establishment which thinks it knows better.
Right.
I mean, how do you tell parents to hang in there and keep at this?
Well, what I do is talk to my own kid about how his brain works. It's called metacognition, and you just talk to him about my 16-year-old, like play with your brain. Go to school every day and play with your brain. Try to build it, and that's very subversive.
Very subversive. Neat. Okay. Alanna, it's good of you to come in today and spend so much time with us on this. Neuroscience in Education. Alanna Mitchell, the 2008 Atkinson Fellow. Thanks so much.
Thanks, Steve.